Things are about to get a little bit different now. Bacteria can multiply at an alarming rate when each bacteria splits into 2 cells, thus doubling. What? Okay, that's important. If we start with only one bacterium, oh, that sounds like an original amount to me, which can double, that's important, every hour, that's important. How many bacteria will we have by the end of one day? That's important. I keep underlining important things. What did you not see? Well, lots of things, but you never saw a percent. What you did see was a growth factor. So we're over here, y equals AB to the x. People use different variables for this, but it's that. So y equals, we'll put it over here, y equals AB to the x. Okay, let's write some things down. We start with only one bacterium. So the original amount, not P, in this context it would be A. So the original amount is 1. By the way, notice that when we graphed these in a previous lesson, and I'm just about to grab that lesson over here on the side, but when we graphed these in a previous lesson, we were talking about the fact that that number in the front is the y-intercept. So we had A times B to the x. That's what we're dealing with here. So the original amount is 1. It starts with that 1. Okay. The growth factor in this case is going to be 2 because we're doubling. All right. And then, let's see, we start with one bacterium, we double every hour. How many bacteria will we have by the end of one day? Okay, so the amount of time is going to be 24, well, hours. So what they're asking is, how many will there be total? So y equals what? Well, we're about to figure out what that what is. We're going to figure it out. So let's just figure out what y is. So y equals A times B to the x. There we go. And at this point, we're solving for y, but y is already by itself. So there's really nothing much to do. So y equals 1 times 2 to the 24. So 2 to the 24 is all they're really asking us to do. It's going to be a huge number. 2 to the 24th power is 16,777,216 bacteria. Wow, that is quite a lot of bacteria. I told you it was alarming. So if they double every hour, at the end of 24 hours, we have this many bacteria. So now we're going to go to the next problem. And we're going to start with one bacterium. In how many hours will there be 2,048 bacteria? Okay, so, well, I'm glad you asked about it. Let's do it. So we are still going to start with 1. And we are still doubling our growth factor, which of course is the B right here. That is the growth factor. In this case, it's 2. B is going to be, well, 2. And in how many hours? Now they're saying, okay, tell me what the time is going to be. Tell me what time frame you're dealing with. And so that's the X. And then they said after time has elapsed, there are 2,048. So 2048 is going to go right here. So now they've given us stuff to fill in everything except the exponent. This one's going to turn into a logarithm. So we have 2048 equals A, B to the X. Okay, well that 1 is somewhat irrelevant. So 2048 equals 1. So go away 1 times 2 to the X. And now we have something that is in exponential form. It's ready to turn into a logarithm, so we'll bring the work up here. Log base 2 of 2048 equals x. And we can just take the log of this, figure it out. Log base 2 of 2048, and that is 11. So it takes 11 hours, and we'll put this in context. 11 hours, we'll put that word. There we go. All right. Number 8, each year the local country club sponsors a tennis tournament. Play starts with 128 participants. Well, first of all, if you read through the whole thing, you'll realize that we do not have a percent. What we do have is a growth factor or decay factor, AB to the X. And they tell us that we start with 128 participants. And during each round, half of the players are eliminated. This right here, that's B. That is your decay factor, your growth factor or your decay factor. So B is going to be 1/2. And then how many players remain? Okay, that is the amount after time has elapsed. So we don't know what that is, but we do know how much time has elapsed. And it's not technically time so much as it is the rounds of play, but it is measured in, it is kind of a time sense, like 5 time periods have passed. Okay, let's fill this in, figure it out. So y equals, whoops, wrong color. Y equals, well, that was nearly tragic, wasn't it? 128 times 1/2 to the 5th power. And I would love to solve for y, but y is already by itself. So don't make your life harder than it is. And we might be tempted to be like, well, I got to divide by 128. No. I'm not solving for a variable up here. I already have y all by itself. Type this. That's it. That's all you got to do. Actually, I can save you the trouble. 1/2 to the 5th. Well, 2 to the 5th is 32. So 128 divided by 32. 128 times 1 over 32. It's 4. So there are 4 players that remain at the end of 5 rounds. Okay, next problem. How many rounds of play are there? Let's rephrase that. How many time periods would there be in the NCAA tournament? Now you could look at a bracket and figure it out, but this is kind of cool the way we are going to do it this way. There are 64 teams at the beginning. The original amount is 64. And this is not in the problem, but it is somewhat common sense. At the end of each play, half of the teams are eliminated. At the end of each round, half the teams are eliminated. You're going to go from 64 to 32, 32 to 16, So the decay factor is an understood 1/2. Okay, how many rounds of play are there in the NCAA tournament? Well, when the whole tournament's over, how many winners do you have? 1. So the amount of teams remaining after time has elapsed is 1. You start with 64 and you eliminate half of them every time. So y equals ab to the x. And we're going to plug the numbers in. So let's see. 1 equals 64 times 1/2 to the x. Now things get a little tricky. I'm tempted to multiply 64 times 1/2, and I dare not. What I will do instead is divide by 64. And don't grab a calculator and divide by 64. Please don't. You're just going to have 1/64 equals 1/2 to the x. Now, one way of looking at this is saying, okay, 1 to any power is going to give me 1. 2 to what power gives me 64? And I'll go ahead and tell you it's 6. But if you also want to turn it into a logarithm with fractions, you can. Log base 1/2 of 1 over 64. Because of the fractions, I'm using parentheses, but you don't have to. And we'll type this in, and we better get 6. So 1/2 goes here, 1/64 goes here, and we're going to get 6. Told you. There are 6 rounds.